With communications such an important part of our lives, reliability of phones and other wireless devices has become critical. It's always been that was for military and aerospace devices, but they no longer have a monopoly on high reliability. Engineers are responsible for designing and testing reliability into RF devices, which was the main point presented by Dr. Chandra Gupta, Senior Engineering Program Manager at Communications Power Industries CPI Beverly Microwave Division. Dr. Gupta spoke to engineers from the Boston chapter of the IEEE Reliability Society on September 13, 2017 at MIT Lincoln Labs. Dr. Chandra Gupta, second from left, with members of the IEEE Reliability Society at MIT Lincoln Labs. Size, weight, power, and cost swap make the job of designing reliably parts ever more difficult. Everything is getting thinner and smaller, noted Gupta. You don't get something for nothing. Smaller sizes result in higher current densities. Everything fails as a result of device physics, he continued. Failures come from electromigration, hot carrier injection effects, galvanic effects, excessive operating temperature, whisker growth, electrostatic discharge (ESD), and electrical overstress (EOS). We want devices that last and be available a long time, said Gupta. It's all about mean time to failure (MTTF) from electromigration, shown here through Black's equation. Soldering also results in weaknesses. During the soldering process, metals diffuse, from which voids, gaps in the material, can grow. Ever thinner wire bonds also produce voids. These problems occur under wire top junctions, causing open circuits. It's a function of the wire width, which is now down to 0.6 mil. When wire bonds were 2 mils thick, noted Gupta, we didn't see these void problems. Additional problems arise from 2.5D and 3D package designs as well as low-pitch bow grids. 3D, noted Gupta, use silicon vias to make connections, which create potential weak points. ESD is a particularly difficult reliability problem because its effects aren't always immediate. The current that flows in a device from ESD might not be strong enough to burn out a device, but it can leave the device weakened. Such problems can become evident only after the device is in use, sometime for long periods. EOS problems depend on the pulse width of the disturbance. Gupta suggested that when testing devices, limit EOS pulses 10 milliseconds durations. Pulses of, say, 100 milliseconds or longer can result in devices burning up. In addition to part reliability, Gupta warned about part revisions and obsolescence. He cited examples of where upgrades or cost reductions affect component reliability. Keep a watchful eye on parts and manage your supply chain. Martin Rowe covers test and measurement for EDN and DE times. Contact him at martin.rowe@aspencore.com. Related articles.